My name is Jim Keller. I'm Vice President of Business Development for North Bay. And today I'm going to do a couple of things. As I thought about the presentation, I wanted to make sure that we were going to provide a couple of things. And as you'll learn about North Bay, we kind of blend two things together. We tend to focus on business outcomes and solving business problems. And we marry that with the technical expertise around Redshift, AWS, and big data and analytics and business intelligence to bring those two worlds together, whereby you'd be leveraging AWS and a variety of other big data tools to solve core big data and business problems. North Bay is, we're heading into our 7th year. We're a 200-person professional services firm. We're nearing the 200 customer mark, and we've launched well over 250 both public and private solutions. We've been an AWS partner now for nearly 5 years. We are an advanced consulting partner. We were also one of the first consulting partners to obtain the big data competency of AWS. We were also one of 5 consulting partners to be part of the mobile competency launch, and we're now working on IoT as well. So we're all in on AWS. We think it's a profound platform, but there are always other things to consider, and I hope to share some of that with you today. Our business model is one where we help customers in a couple of ways. So we can help you implement, architect, transform anything around big data, data pipeline, data transformation, migration. We can do that through staff augmentation, or we can do that on a project basis. And really, we don't dictate. It's really what our customers want more than anything that drives that. We also use something that's pretty unique in the marketplace, and we call it agile big data. So many of you are familiar with the agile process in terms of software development. Well, we brought that into the big data world. And most of our customers and many of our customers don't really like the Big Bang theory. They really want to see progress and execution and deliverables sooner rather than later. So we leverage the 2-week sprint methodology to show those results. Okay, and I'll show you some of that as we proceed. So from North Bay's perspective, we work with early stage companies, large enterprises, like this large global publisher here, Scholastic, healthcare, tech companies, financial services, publishing, media. There aren't many we haven't worked in some capacity around. And to us, it's not really about size of company. For us, it's more about is what the customer is looking for is aligned with what we do. And that's really what it's all about for us. So as I thought about what to share with you today, I thought there might be 2 interesting use cases that would be interesting. The first is a healthcare customer, Eliza Corporation, back in Boston. We assisted them and have been assisting them around a data lake implementation that also leverages Redshift and a pipeline around all of that. And then the second one is a large global publisher that has been leveraging their IBM AS400 for 20 years and wants and needs to get away from it as quickly as they can. And that's all about data migration and data transformation. In terms of Eliza, let me take you through their story a bit. So Eliza Corporation is in a category called health engagement management. Well, what does that mean? Well, the world today in the healthcare world is all about performance for providers, for insurance companies, and anyone else in the ecosystem. And funding is predicated on outcomes. So they're all trying to figure out how to measure outcomes. So if you ever got a phone call that said, have you been to your doctor in the last 30 days? Okay, somebody probably paid Eliza to run that campaign to go ask you. Okay, and in their lifespan, they're approaching the 2 billion interaction level. And as we think about what matters to them, HIPAA compliance matters, PHI matters, so security, compliance, data protection is of the highest importance. But so is the amount of data that they're processing, and I'll take you through the variability of what that is, and the high volume of that semi-structured data that they're processing on a minute-by-minute basis. And they have many consumers downstream of that data, which yields some pretty complex problems in terms of trying to architect a solution that can accommodate those varying consumers on the other end of that pipeline. Blue Cross Blue Shield might contract with Eliza to run a program. I call them campaigns, they call them programs. And Blue Cross will say, Eliza, I want to come up with a custom program whereby you survey every diabetic in the United States within the next 2 weeks, based on all the data you have and all the data we have. And we want to know how many of those have visited the doctor in the last 30 days. That's a program, that's an outreach, that's an interaction. So through one of the channels that they use, they'll ask the question, did you visit a physician in the last 30 days? And if it's on the phone, if you didn't hang up and you actually answered them, then we'd have that response. So imagine a series of those programs or campaigns, hundreds and hundreds of them on an annual basis. The questions are different, the answers are different, the channel through which the answers are derived are different, and the answers you actually give are all different. There were a handful of goals that really, when Eliza approached us, that really mattered to them. For them, it's all about scale of the business. It's acquiring new customers, it's handling more interactions, and it's providing more value downstream. So really this notion of a next generation or data architecture was hugely important. Decoupling storage and compute was also of highest value. But the other thing that was really material to them over the course of their lifetime, they had this challenge. The challenge was they would absorb data, it would be touched multiple times, and they never kept the single truth of data, which was the original data to begin with. So they really wanted that data system of truth, if you will, as part of that architecture. They also had the need to deal with both batch processing and near real-time, or in fact real-time, and others here, governance, entitlements, access rights, et cetera, and HIPAA compliance I already mentioned. So this whole notion of storing the original data as it was coming in, and not as they were doing, trying to transform that data on the way in, on the inbound side, but absorb it quickly and then transform it when needed based upon the consumption pattern, was really the profound architectural challenge that we were trying to face. So we proposed a data lake using S3, and I'll get into the architecture in a minute, with really sort of this notion of a hub and spoke pattern. So single data, source of truth, and then the consumers and others alongside. And they have a series of downstream consumers, which they do heavy statistical processing using solutions such as Vertica. And then I already talked about the notion of streaming and batch. This is a framework architecture that we use for most of our solutions involving a data lake. So if we go left to right, you have a series of inbound data. Could be batch, could be streaming, multiple sources, multiple timings, but that needs to be absorbed and stored quickly. Now the other thing that's unique about Eliza's business is I mentioned those surveys, right? So each program for each customer is custom and different. So Blue Cross might contract for 150 of those in a year, and each one of them is uniquely different, targeting different demographics, different geographies, et cetera. It's also proven that the various teams at Eliza could construct those programs any way they wanted. So just think about a very simple example, zip code. How many different ways do you think you can term and label zip code? In Eliza's case, nearly 20. So now think about normalizing all of that so that whenever you want the answer, I want to target zip code X or what happened within these zip codes, you might actually be able to derive the answer. So this whole notion of governance and data quality is hugely important in terms of standardization of the data. And then as you proceed, getting it into the lake and storing it that way. So now we have the data, and then we can then subsequently transform it, and we can also archive it. Then moving it through, and if we go to the far right for a minute, these are the consumers, right? So it could be a website, could be a web portal, could be an analytics package, could be a BI tool, could be QuickSight, could be many things. So as those requestors or consumers are looking for their data, we need to make sure that the access rights are aligned and the entitlements are correct, particularly in the healthcare world, but certainly in most worlds, so that Blue Cross for program 20 can only access the data they're entitled to access. And this is all wrapped around, has a wrap around it with a standard API set of calls so that every requester and anything going on the inbound side is in a standardized way. The goal here is to eliminate human touch, create a standardized process, and to reduce the amount of variability through the entire chain. So as phone calls are coming in, that's real time or near real time. Eliza has a NOC as well, so they're running their own network. They're running that IVR system. So we're pulling that data in. At the same time, you see at the top of that, you see Kinesis Analytics. So the customers, the program leaders and customers also want to know what's happening. I launched the program this morning. I'm doing 3,000 calls a minute. How many answers am I getting? Are we being effective? Is the quality of the answers good, bad, or indifferent? So we need to know all of that, particularly if we need to make adjustments. So we've got the Kinesis stream. So this is the whole data absorption, data source front end of that speeder, if you will. And then again, we move into the data governance side of it. So you'll see things like Lambda. So programs running. Lambda says, oh, I just got a response X. I need to go do something with it. Now I can go do something with it. As we continue to proceed to the right, there are really three things in a data lake architecture that make it a data lake architecture, right? So I need metadata, or essentially a catalog of everything that's happening from a data and a data source perspective. I need to store it. In this case, the data is stored as a repository in S3, and I need to have access rights and credentialing that's assigned to and aligned with that data. And then once you get there, we can talk about archiving and whether Glacier is important or what the retention, in HIPAA-compliant organizations, retention is very important, and there's a prescribed legal amount of time they have to retain the data. So all that matters. There's a discovery aspect of this as well, where the metadata comes into play, right? So if someone is looking for or doing searches on that vast amounts of data, you can invoke things like cloud search to be able to query that metadata to start deriving your answer. And then as we proceed to the right-hand side, you have the consumption patterns, right? So the top portion, Eliza's customers have the ability to log into a portal and see what's happening. And we're using Presto and EMR for that. Then they have a BI tool. They have an enterprise-wide solution of Tableau. As I said, they do some pretty heavy-duty statistical processing using SAS. Okay, so the consumption patterns dictate the schemas that we're using within Redshift. So think about this again, right? Get the data in fast, store it in S3 as quickly as we can in some reasonably random order, but that never gets touched or changed by machine or human. And then execute the Redshift portion of that in terms of the schemas that are required to answer the questions that the downstream folks are looking to answer. And then there's also third parties that have access to it as well, and that's kind of the lower portion of that. So in terms of Redshift specifically, data pipeline is used pretty heavily here, as you can imagine. And then the data is ETL'd into Redshift. And that is the repository or the warehouse that Eliza uses every minute of every day to run their business. And then Redshift, again, feeds those downstream consumption tools, whether it be the portal or Tableau or numerous others. You see that Dirt, that's an internal custom-built tool that Eliza had built and continues to use today. So just so everyone understands what the moniker is there. Prior state for Eliza was multiple copies of Redshift everywhere. Every constituent, every customer, every internal customer, there was data everywhere. It was getting changed multiple times. Now we have as a standardized pipeline process, all wrapped with a standard API that's controlled. that the auditors can feel comfortable with in terms of access rights. And we can always go back to the data system of truth if we ever have a question about what data actually came in, whenever it came in. And just to give you kind of a quick inventory, these are most of, if not all of the services that we took advantage of as we architected this. This is a bit of what I summarized before, right? So prior to this implementation, Eliza was taking the hit on the right side of the data. I mean, they were trying to transform it on the fly, which was painful. And it's okay when you're starting with 1 or 2 programs for 1 or 2 customers. You can sort of rationalize how you might do that. But you start scaling hundreds of customers and hundreds of programs every minute of every day, and that's where it starts getting to be problematic. And then this whole notion of managing costs becomes really important as well. So there's a whole other layer of this for those of you that have been using AWS. You know, when you start employing reserved instances, and the whole notion of managing the infrastructure is a whole nother layer of intellect, knowledge, and complexity you need to think about as you architect this. As I focus on learnings, there's a couple of takeaways that were pretty evident. So if you're dealing with a HIPAA-based environment, it's its own world for those of you that lived within healthcare. Get in front of that fast and understand the requirements, because there are specific things you have to do or are encouraged to do that you want to make sure are part of your core architecture. The second thing is, I kind of mentioned the data governance portion. So Eliza has well over 1,000 attributes that they have to standardize. Okay, first name, last name, full name, surname, you know, just it goes on and on and on, right? So particularly within most enterprises, the governance model is a journey in and of itself in terms of getting standardization within the organization around what the governance of the data should be and what that final outcome should be before you ever get to program anything or implement anything. Okay, we tried to and did do it in parallel due to time constraints, because the customer's always right and their deadline is always the deadline. But it is something you really need to consider, because it can thwart the speed with which you can actually implement the solution. And the other thing is, and this is kind of a common theme too, not every tool works within the cloud environment or interacts nicely with the cloud environment. So that's where those POCs come into play, all right? So if you have on-prem tools or behind your DMZ and it needs to talk to the cloud and AWS, that's a perfect place to try a little POC to make sure that actually will work before you decide to go full boat into the architecture. And then lastly, and this is, you know, I keep talking about this everywhere I go, big data projects are human change management projects. They really are. So don't underestimate all of that. And when I get into my next case study, you'll see more of that come to light. But in the end, most organizations have highly trained staff that are highly valuable, have done things a certain way. So there's that churn. There's the infrastructure team and the security team and the governance team. So there's humans are humans. So don't underestimate taking them along that technical journey. So now I'm going to move to a global mainline publisher. And we all know that publishing is undergoing its own challenges in terms of, if you've been an offline publisher for years, what do? Right? Well, that's what this organization was really facing. So I'm going to kind of take you through, again, kind of the business aspects of this, the technical challenges that they were dealing with. How do you move from a paper-based company to something that looks very modern and very different? And how does big data and Redshift help that? And their whole notion was, as Netflix and Amazon have been paradigm changers in the marketplace, the same thing is needed in the publishing world. So how does this global publisher transform itself in that light? And then we'll talk about the technical architecture, and then my favorite part, which is lessons learned. So this publisher is over 100 years old. He is in fact purely paper-based, but they really have this notion that ebooks can transform their business and will transform this business. So think about, for those of us that went to school more than 5 years ago, You might have gone to school and all of a sudden a certain publisher had a certain bookmobile show up in the parking lot, which had maybe a couple hundred titles, and you as students, through your teachers, could buy those books from the van. So how do you turn physical into digital? Okay. This publisher runs hundreds of thousands of those mobile bookstores every year. So they have this vast amount of existing data, but they also are going to have new data. And that's where this notion of our catchphrase, which is teaching old data new tricks. The common notion is that all your old data is either going to get thrown away, it's going to get changed dramatically. Well, that's not necessarily the case. The key is to unlock it, put it into a form that's consumable, and allow your business users to do something with it. That's really the magic. And in their case, they're on an old IBM mainframe, which I'll talk about. These are their words, old and creaking, not mine. I'm not making judgments. But in the end, and to emphasize this, many IT projects are kind of TCO based, right? The genesis of the project was, how do we reduce total cost of ownership? That, in fact, was not the reason for this initiative. Yes, they wanted to reduce TCO, but that was secondary to transforming their entire business so that there actually would be a business. That's how profoundly impactful this needed to be for them. So in terms of the goals that we set out with them on the onset, and I will say, as part of what North Bay does on a regular basis, we're very much key performance indicator driven. We're very much outcomes based. It's not about let's create a new architecture. It's about what are your 5 or 10 strategic business goals at a global level and then at a business unit level. And then we drive all of that down. And then once you start implementing, then you drive it back up to make sure you're actually achieving those KPIs. Because without them, you put a new engine in the car, but the car may not go any faster. And again, this whole blend of old data, new data. So we've got a vast amount of old data, but they want to take in this near real-time or real-time streaming data from POS systems and many other places, and then have that be actionable. And then lastly, which is another common theme with many of our customers, this whole notion of end user self-service enablement. Okay, so how many of you have been in a situation where end user X submits a ticket, they want you to create a report so they can go and analyze this fact and this dimension across this time sequence. And they're waiting 4 days, 5 days, 14 days, a month. And now the data they asked for is totally irrelevant because they needed it in an hour. Right, so this whole notion of empowering the end users to do their own thing. IT gets to manage everything in a standardized way, but give the keys to the car to the end user, let them do what they need to do in as near real time as possible. This publisher has been running on an AS400 for 20 years. They have over 5,500 workloads. They have over 350 SQL workloads. In their words, costly to maintain. I could use different words. And this whole notion of end user enablement. So this publisher has something interesting. They actually have SLAs with their end user business units in terms of turnaround time. And they aren't able to actually meet those SLAs. Critical thing we learned and critical thing they shared. Just to give you some context for reality, because I know we're at AWS and I thank them for inviting me and North Bay here, but this publisher considered many options. It was a pretty thorough review, right? So they have invested in IBM. They've invested their resources in terms of training and skills and tools around IBM and the AS400. So they certainly evaluated the possibility of upgrading within the IBM framework, as they did the possibility of migrating to SQL Server and upgrading all the componentry. They looked at maybe a hybrid model where they'd have some on-prem, they'd use AWS for hosting and storage, and kind of this Uber hybrid model that they started sort of wrestled with. Maybe leverage AWS for a core set of tools and services, but then leverage a whole host of other non-AWS tools and services to achieve business results for their end users. So this went on for a pretty significant amount of time. Okay, particularly if you're going from on-prem to cloud and that whole review of migration and how you even do that, what do you consider, get all your constituents on board. And this notion of, do you select purpose-specific tools, best of breed, versus using a family of services from one vendor, right? And I'll get into some of that in a minute. And they have many, many staff members that have been trained on SQL and relational databases. So what do we do with that? And how do we leverage that investment? And then they also realized that they couldn't do it by themselves, which is how North Bay got involved. I'll let you read these, but they went through a pretty rigorous evaluation process to make sure there was alignment in terms of the business, the tech team, the cost structure. Because oftentimes what's forgotten as well, and I'll show this in the architecture, is what DevOps needs, right? How do you understand the health of the system? How do you understand what's going on? How do you measure that? How to react to it? And they use this Control M scheduler as the, it is the linchpin to running everything on-prem for them. And that wasn't going to go away anytime soon. What we agreed to do with them, you may remember I said that customers nor us like the Big Bang Theory of big data. So we agreed on a 3-month pilot. And we said, let's take a subset of workloads. Let's derive a V1 architecture and pipeline, leveraging AWS. Let's demonstrate to ourselves from a technical perspective and to business owners that we can actually deal with old data, deal with new data and streams, put it into a format that's consumable so the end users can do something with it. And let's go prove that to ourselves internally before we go and move all in. And at the same time, oh, by the way, now I have a series of technical folks at the publisher that need to get trained up on AWS. Tools, services, best practices, that's not going to happen overnight. So let's kind of take them gradually along as we evolve the architecture and the platform. And then, as I said, prove to the business users, to the IT team, and to us, North Bay, that what we're formulating is actually going to work. So what happened was pretty profound. We actually executed the 3-month pilot in less than 3 months. And when our business sponsor and the executive at the publisher went to the CEO, the sponsor said, we were planning this for 3 years. I actually believe we can do it in half that time. And the way that we devised doing that was to create parallel work teams in conjunction with parallel work streams. So what we did, in fact, was we created a series of work teams. We chose a series of streams, and those are all working in parallel to go execute the migration, all simultaneously based upon the framework we've derived. So the CEO moved the entire budget up, and now we're on the 18-month sprint, if you will, to get it all done. And I mentioned these work streams and work teams. I'll give you a little bit of insight. So I talked about the book fairs, these mobile pop-up vans, if you will. We're talking about 5 to 6 million rows a day, 6 to 7 gig a day, just for that. Billion rows daily in Redshift. So just trying to give you an order of magnitude. They have a financial system. They have their education group, 60 million records in that table. They have a reading club, a Canadian business. We found some ways to save money there. And they also identified, with the help of AMR and a few others, a revenue opportunity of over $300 million as we went through this exercise as well. So I'm not going to expect you to read this, but essentially what this looks like is North Bay has dozens of folks working with them right now. Each team has about 6 to 8 folks. Each team has a categorized set of workloads that they're focused on, and each of those teams is working in parallel. They're all integrated, so we do daily scrums, we do sprint planning, we do stories and epics, so we do all of that. And we use tools like HipChat and Slack to make sure that collaboration is in sync on a consistent basis. But this really becomes a factory, if you will, in terms of getting that data from one place to another. So what does the architecture actually look like? So what's not shown in this diagram is over on the far left are all their operational systems. So their POS systems, their customer service systems, all those operational systems. So there's all sorts of data back here to the left. They all do that on-prem, get it to the AS400, and that's when it's available to the new platform and new pipeline to commence processing. So as I mentioned, Control M is their scheduler. So it knows when files are available. We use data pipeline to execute those and manage those, the jobs running. Each job correlates to a work stream, which correlates to a file. Those get grouped into job groups. We use Scoop from a pull perspective from the mainframe running on EMR. Now, I talked about some of those things that we kind of discover as we go along. So it turns out there's a limit to how many parallel connections you can have to the AS400 through Scoop to actually pull data, right? And that's somewhere between 16 and 20. Okay, so it's self-limiting. It is what it is. And I should add, this is a phase 1 architecture. Ultimately, when we're done, the whole mainframe thing's gone, and we're pulling the data directly near real-time or real-time from their operational systems. That's phase 2. That's coming. So these jobs are running. We have the metadata stored in DynamoDB. Data pipeline is managing those interactions. We're getting it into S3. Now, another thing, again, I talked about POCs and those kinds of things. So in terms of spinning up an EMR cluster, so it takes about 10 minutes. When we first decided to do it, we said, all right, well, we'll spin it up when we need it, and we'll get going. Well, we spun it up, we're waiting. So now we just, data pipeline cranks it up, it's ready, so it's ready to go, so we're not waiting. Same with EC2. So the things you kind of find along the way as you're going through these kinds of initiatives. So we're taking the data from S3, what you heard in the last presentation, use the copy command, and then there's really 2 versions of Redshift here that you see. So Redshift, we call it staging. So essentially that is all of the data columnarized without thinking about facts and dimensions. Okay, so we're not losing any data. It's still organized, but we haven't reduced it to the point where it's truly dealing with just facts and dimensions for the downstream consumers. So all the data is always there in that form. This publisher has leveraged Tableau enterprise-wide, hundreds of users, and that's what they're going to use, at least for the foreseeable future. So what the publisher and ourselves have done is we've identified those facts and dimensions and what's required for those reports. And the actual Redshift data warehouse is what houses that data for the pure purpose of allowing it to be consumed by the end users. So in this case, 2 instances of Redshift, 2 different purposes. Now the other thing that's important, again, I mentioned, what is the operations team thinking about? Well, they'd kind of like to know what's happening as we go through all these processes, right? So the lower portion of this visual shows you what's happening. So Lambda knows an event, job started, job ended, oops, something happened. So it's tracking all of that, leverage SNS for notifications. So the operational side of the publisher now has visibility on an ongoing basis to understand what's happening with each of these jobs. Cycle time, success complete, success fail, couldn't do the connection, oh, wait a minute, we can't do that many connections at the same time, et cetera, et cetera, et cetera. There's a whole nother layer of technical detail behind this, but in terms of overall architecture and where Redshift fits in, this is the architecture that's been adopted officially by the publisher, and will be the framework for moving forward. So why AWS? The publisher really wanted managed services in the truest sense, and AWS provided them that for the most part across the board. And then all the stuff you get with AWS in terms of security and elasticity and all of that. The publisher had familiarity with relational databases, so Redshift made sense in terms of an enterprise data warehouse platform. S3, as it most oftentimes is, goes for itself. And then North Bay has had the privilege of working with them because of our expertise around the whole migration and big data. I love this phrase, came from the business sponsor there. It's not auto magic. You don't just press on and everything just spins up like a jet airplane and all of a sudden the air conditioner comes on and the lights come on, and we wish to work that way, okay? You actually have to work at it. There were custom tools because every installation is different, every organization is different, everyone wants to do it their own way. Okay, that's just a reality as well. But the big thing that's driven success here is something we have termed the one team model. So I talked about those work streams and work teams. It is one team. It's thought of as one team, it's managed as one team, it's integrated as one team. And then the other thing that's pretty critical is, as you start formulating, you do POCs, you do MVPs, the costs look great. Oh, my bill was $2,222 last month. I can live with this. And then as you start building up, as a jet airplane, as engine 2 starts cranking up, and as engine 3 starts cranking up, and then when you get the 4th engine going, all of a sudden you're like, oops. Right, so don't lose sight of that. That's the message there, because the cost can creep up. The TCO is still impactful. There's no question about that in terms of where it was versus where it is. But it's not something you want to kind of put on autopilot. The other two things I'll leave you with in this particular case, and one thing the publisher did that I thought was pretty compelling and unique. So they understood that given the size of their enterprise, adoption and pull-through was a big deal and a challenge. So they actually instituted this notion of two roles. One is called a data champion, and the other is called a data coach. So the data champion is on the business user side. That's the person that's charged with and empowered to understand what data they need, when do they need it, what is the SLA, and how do they feed the end users of that business unit to drive success. That's their role. They're on the team. And then from the IT perspective, there's a role called the data champion. Same thing in the inverse. Their job is to work with the business user and the data coach to make sure that there's an understanding and clarity around what they need so that the architecture and the framework we put in place can succeed. And then lastly, I mentioned this notion of agile big data, which is what North Bay subscribes to. And every customer that we interact with is in a different life cycle of agile. Some say they do agile, and all that really means is they use Jira. Some do agile and they really live it and breathe it, and they have someone actually called a Scrum Master, and they do all that. This publisher was kind of on the early stages of the agile adoption. So we actually recommended, and they embraced it. They actually brought in an agile coach who worked in parallel with the work we were doing to help the publisher's team understand what agile was, how to take advantage of it, the principles behind it, and also help them adapt to it, because every organization needs to embrace agile in their own way, right? There's no dramatic structure around that. So again, it's a change management project as much as it is a data project. We are now on, I think we're through, we're nearing the 300 workload mark in terms of the migrations to date. We have another 14 months or so, maybe less, but we're well on our way. We know what the roadmap is. We've got the work teams in place, so that'll happen pretty naturally. So I hope those two use cases were of help.